Assalamualaikum students, how are you all? So you all are fine. Today the topic which I am going to present, it is about Rolle's theorem and mean value theorem. So what are the objectives of today's lesson? That you will understand and then you can use the Rolle's theorem. That's where you can use this theorem and you understand and use the mean value theorem. Now what is Rolle's theorem? That and this graph, you can see in this graph, if you will connect 2 points A and B, there are 2 points in this A graph, point A and point B. When the value of x is A, so you will get the function f of A. At point A, the value of the function is f of A, and at point B, the value of the function f of B. And you can see here in this graph, f of A is equal to f of B because they both are having the same distance. So if you connect from f of A to f of B with a smooth curve, there will be at least one place where the derivative of the function is 0. So now what we will do, we will connect this point A and B with the smooth curve. So when you will connect these 2 points A and B with smooth curve, so there at least one point, you can at point C, you can see that between A and B there is one point C. You can see here at point C, the derivative of the function at that point, you can say here f dash of C at that point, the derivative of the function is 0 between these 2 points A and B. So what is the Rolle theorem? The Rolle theorem is saying that if there are 2 points A and B and such that f of A is equal to f of B, and when you will connect these 2 points with a smooth curve, so there must be at least one point between A and B where the derivative of the function is equal to 0. So in this, here you can see here that how can you join the 2 points. So look at the first graph of this theorem. Here you can see here that there are 2 points A and point B, and they are connected with a smooth curve. So in this smooth curve there is at least one point, it can be more than one, where you can see when I will draw the tangent line at point C. When I will draw a tangent line at point C, you can see here the tangent line is parallel to x-axis. So at that point the derivative of the function f dash of C is equal to 0. So at that point the derivative of the function is 0. So about this graph you can see, you can say that here Rolle's theorem is an important basic result about differentiable function. Like many basic result in the calculus, it seems very obvious. What the Rolle's theorem is saying, that it just say that between any 2 points where the graph of the function is differentiable, the graph of the differentiable function f of x cuts the horizontal line, there must be a point where f dash of x is equal to 0. You can illustrate this theorem with the help of diagram. The first figure is saying that there are 2 points A and B, and you can see here that f of A is equal to f, because A and B both are having the same height. A and B are having the same height, so you can say f of A is equal to f of B, or you can see here the f is continuous from the closed interval. Okay, so A to B the function is closed, and in this closed interval the function is continuous everywhere. You can take a tangent line at in this curve, you can take tangent line at each point, so it is continuous and differentiable as well in the open interval. Okay, so for differentiable we will take the open interval, because at the end point the function is not cannot be differentiable at the end point. But in the second figure you can see here the f is continuous on the closed interval. In the second figure you can see here a function is continuous from a closed interval a to b, because there is no jump, no break in this graph, so it is continuous, but it is not differentiable because we cannot take a tangent, because the derivative means the slope of the tangent line. So the second graph of the function is continuous, but it is not differentiable. So if it is not differentiable, so it means you cannot take a point f dash of C between this interval. So you cannot apply here the Rolle's theorem. in the second graph. So finally we will move toward we will write definition for the Rolle's theorem, that what the Rolle's theorem is saying, that if two points at the same height, you can see here in the previous graph that A and B are having the 2 points the same heights, point A and point B are the 2 points which are having the same height. Okay, and next is saying that are connected by a continuous and differentiable function. So you can see in the first graph of the figure here the function f of E is equal to f of B, and the graph between these point, the function is graph of this function is it is continuous and it is differentiable also. So what the Rolle theorem is saying, that if two points at the same height are connected by a continuous and differentiable, they must be continuous and differentiable, then there is at least one place between the points A and B, between those 2 points, where the derivative or the slope is 0. So you can see here in the first figure, that the f of, in this closed interval A and B, f of A is equal to f of B because both are having the same height, and between A to B the function is continuous on the closed interval and it is differentiable also. So it means there at least one point C, you can see here the point of relative maxima. At this point the derivative of the function is 0. So that is all about the Rolle's theorem. So now we move toward the mathematical definition for the Rolle's theorem, that what the Rolle's theorem is saying, that if f of x is continuous on the closed interval, if there is a function and it is continuous on the closed interval, and f is differentiable on open interval, we are taking the open interval here because at the end point function not be differentiable, and A and B are the points which are having the same height, so f of A is equal to f of B. Then if these three conditions will satisfy, so then there is at least one value of x, on the open interval AB. Between these 2 points there is at least one point C, you can see that point is C, call it C, such that the derivative at that point will be equal to 0. So you can see here in this graph, that is the graph of a function, and you can see here that A and B are having the same height. So the first condition is satisfying here because f of A is equal to f of B because both are having the same height. So f of A is equal to f of B, so first condition is satisfied, one of the conditions is satisfied, third one, and you can see here this graph is smooth within this closed interval. So the first condition is satisfied for this graph, that function is continuous between this closed interval A and B, and this function is differentiable also open the interval. For differentiability we are taking the open interval. So in this graph you can check here that f of A is equal to f of B, they are having the same height, f is continuous on the closed interval, and if it is differentiable as well in the open interval. So it means there must be at least one points between A and B. There you can see here there are 2 points where the derivative of the function is 0 when I will take a tangent line. So between these 2 points there are 2 points C1 and C2. These are the 2 points. At these 2 points the derivative of the function is f dash of C is equal to 0. So in both of these 2 points C1 and C2, here the derivative of the function is 0. So because according to definition it is saying that at least, so it can be 1 or it can be more than 1. These are some of the examples for that is example for Rolle's theorem, that how can you verify the Rolle's theorem. So if a function f of x is given, that is x4 minus 2x square, and the interval is also given. So as you know that this is a polynomial, so the polynomials are always continuous and differentiable, so no need to check for this continuity and differentiability for this function. So there are three conditions for the Rolle's theorem: that the function must be continuous on the closed interval, it must be differentiable on the open interval, and f of e is equal to f of b. So here now we are considering a is -2 and b is 2. So just put these values in a function. So if I will put the value of a, like for example, if I will put the value of x is -2 in a function, so it will come value of f of -2, and value of f of 2 is also. So f of a is equal to f of b. Both are having the same answer, that is 8. So this condition is also satisfied here, because Rolle's theorems are having the three conditions: the function must be continuous, differentiable, and the value of the function is equal to the values of the function must be equal. So you can see here f of a and f of b are both are equal to 8. So since the Rolle's theorem we can apply here. Now what are the, according to the formula that we will use here, the formula that Rolle's theorem is saying that if there at least if three conditions will satisfy, function is continuous, differentiable, and f of a is equal to f of b, then there must be a point c between this interval where the derivative of the function is 0. So now we will find that point. We will find the values of c where the derivative of the function is 0. So for this we will differentiate the original function. To find f dash of c, first we will differentiate the function f dash of x we will find. So you can see here f dash of x is equal to 4x into x square minus 1. So that is the value of f dash of x. So f dash of x is, in this function, what is f dash of x? It is equal to 4x into x square minus 1. That is f dash of x. Now according to the condition you have to take f dash of c is equal to 0. So now I will take this f dash of x equal to 0. So then I can find that value of c. So I will take f dash of x equal to 0. So when I will take 4x into x square minus 1, I will take it equal to 0. So the two roots of this equation will come, sorry, three roots. So the roots are x is equal to -1, x is equal to 0, or x is equal to 1. So these are the points. So these are the values of c. These are the values of c. C is -1, c is 0, and c is equal to 1. So these are the points where the derivative of the function is equal to 0. So in this way you can find that values. We just find the values of c where the derivative of the function, at this point the derivative of the function is equal to 0. So now these are the example. You have to do this, that if the Rolle's theorem we can apply to find the value of c. If we cannot apply the Rolle's theorem, then what is the reason? So these are the examples. You have to do this, do the practice for these questions. Okay, now what is mean value theorem? The mean value theorem is one of the most important theoretical tools in calculus. It states that if f of x is defined, f of x must be defined continuous on the closed interval ab, and f of x is differentiable on the open interval ab, then there is at least one number c in the interval open interval ab. C is a point between a and b such that at that point f dash of c is equal to f of b minus f of a divided by b minus b. Now you can see in this formula, here we are not saying the mean value theorem is the extension of Rolle's theorem. In Rolle's theorem we are saying that if f of a is equal to f of b, so between these 2 points there is one of the points where the derivative of the function is 0. But mean value theorem, according to mean value theorem, it's saying that here we cannot say that f of a is equal to f of b. It can be different. In mean value theorem, f of a is not equal to f of b. But here we are saying that when there at least one point between a and b where the derivative of the function, or you can say the derivative of the tangent line, is equal to the derivative of the secant line. F dash of c is the derivative of the tangent line, and that is equal to f of b minus f of a divided by b minus a. That is the derivative of the secant line. Or in other words, you can say that there exists a point in the interval, open interval AB, which has a horizontal tangent, that there must be a point between A and B where it has horizontal tangent. In fact, the mean value theorem can be stated also in terms of slopes, you can say. Okay, in this number you need that there's f of b minus f of a divided by b minus a, that is the slope of the secant line. So you have to find that point where the slope of the tangent line is equal to the slope of the secant line. Okay, so you can say that f of b minus f of a is the slope of the line passing through the 2 points a into f of a and b into f of b. So the conclusion of the mean value theorem states, what is the conclusion for the mean value theorem? It states that there exists a point such that the tangent line is parallel to the line passing through 2 points A and B. Is when we will join these 2 points A into f of A with the point B into f of B, so there is at least another point where the derivative of the tangent line is equal to the slope of the secant line. This definition you can understand this. Here you can see that is the graph of the function. So there are 2 points A and B are 2 points. So when I will connect these 2 points A and B, so it will be a slope of secant line. Okay, according to the definition, what the definition is saying, that when you will look at this definition, that the mean value theorem states that there exists a point such that the tangent line is parallel to the line passing through A into f of A and B into f of B. So it's mean that we will pass a line between A to f of, if this is a point A, if there's one, that is a point A. So what are the coordinates of this point? The coordinates of these points is, the x value is A, so the y value will be f of A at this point. And similarly, at point B, the value of x value is B, and the value of y here f of B. These are the coordinates of points A and B. So if I will pass a line between these two coordinates, that is a secant line. And as we know, the slope of the secant line is equal to f of b minus f of a divided with b minus a. So what the mean value is saying? The mean value is saying that when you will pass a line between 2 points in a curve, so there at least one point C, you can see here, there is one of the points C between these 2 points A and B. At that point, the slope of the when you will take the slope of the, when you will at point C, when you will take a tangent line, so you can see here this tangent line f dash of C is parallel to secant line. So that is called mean value theorem. That what the mean value theorem is saying, that when you will pass a line between 2 points in a curve, so there at least one point C where the slope of the tangent line will be parallel to the slope of the secant line. So that is all about the mean value theorem. In mean value theorem, we are not saying that f of A is equal to f of B, because if you will take f of A is equal to f of B, so and then the slope of the tangent line will be 0 at that point. So then we will apply the mean value theorem. So finally, now we will write the mathematical definition for the mean value theorem, that f is continuous on closed interval AB, differentiable on open interval B, then there is a point C in open interval AB such that at that point the derivative of the function at the given point C, at a point C, you can see C is a point between A and B. So at that point, the derivative of the function is equal to the slope of the secant line. So in this graph, you can see A, if I will connect this point A with B, so that is the slope of the secant line. That is the formula for this. So it means there is a point. So there is a point between A and B. There is a one of the points C at which the derivative of the tangent line will be equal to the derivative of the. Now you can see here that when I will join the point A with point B, that is the slope of the secant line, there is equal to the slope of the tangent line. So I can take it. I can take different tangent line at this between A and B, but you have to consider that tangent line which is parallel to the secant line. So C is a point. That is a point here at point C. You can see here that f dash of C is parallel to the slope of the secant line, and here we will apply this formula, and that is the formula for mean value theorem. So now that there is one of the example for this, that a function f of x is function is given, interval is also given, so that is another, yeah, that is a polynomial. So we know that polynomials are continuous and differentiable. Okay. So what the mean value theorem? Here we will apply the condition for mean value theorem. So according to mean value theorem, that is saying that f dash of c, the derivative of the tangent line, is equal to the slope of the secant line. So first I will differentiate this function. If I will when I will differentiate this, so it will be 3x square minus 2x minus 2. Now I will take this function, I will solve this function for f dash of c. I have to find the value of c. So as I know that f dash of c, according to formula, f dash of c is equal to f of b. So f of b means you have to put the value here. A is minus 1 and b is 1. So put the value of b1 in the original function. So your f of b will be minus 2. F of a is 0 and divide with b minus a. So b is 1 and a is negative 1. So f dash of c will come negative 1. So and now take the function f dash of x and replace x with c and take this value equal to negative 1. So when you will solve this, you can find the values of c. Now c there are two values for c. So there are two tangent lines which are parallel to the secant line. There is another example for this. When you will solve this equation, that is, find all values of c in the open interval a b such that you have to find all of the values between c. It may be 1, it may be more than 1, where f dash of c is equal to f of b minus f of a divided with b minus 1. So I will take a function, and in this function first I will find f of b. So now b is f of 2 minus f of a is 1 by 2, and put these values in original function. So f of 2 will be 3 by 2 and f of 1 by 2 is 3, and divide with b minus a. So b is 2 and a is half of 2. So when you will solve this, so it will equal to negative 1. That is, the value of f of b minus f of a divided by b minus 1 is equal to negative 1. Now I have to find f dash of c. For f dash of c, I will differentiate the original function. So when you will differentiate the function, your answer will be negative 1 by x square. So here that this is value of f dash of c is equal to negative 1 by x square, but replace x with c because we have to find f dash of c. So replace x with c. So when you will replace x with c, so f dash of c will be equal to negative 1 by c square. So when you will solve this, the value of c will come. So it's that this is the value of c where the derivative of the tangent line at that point, at point 1, 1 is a point between a and b where the derivative at point 1 is parallel to the derivative of a secant line. So these are the different examples for the function, that how can you check there that it is that can we apply the Rolle's theorem or can we apply the mean value theorem. So suppose we have a function f of x is equal to x square, in the interval is also given 1 and 3. So mean value theorem state that there exists, according to mean value theorem is saying that there is a point C between this interval 1 and 3, that where f dash of C is equal to f of b minus f of a divided by b minus a. So now we have to find that point. So according to that point, now my b value is 3 and a value is 1. So just put the value of 1 and 3 in the original function. So I have to find f of 3 minus f of n divided with 3 minus 1. So when I will solve this, when you will put the value of x3 and 1 in the function, and after simplification your answer will be 8 divided with 2. So f dash of c is equal to 4. Now according to the formula, what this value of 4 means, it is a value for the secant line. F of b minus f of a divided with b minus a is equal to 4. So now I have to find that values of c. So find the f dash of x, differentiate the original function. When you will differentiate the original function, it will be equal to 2x, and then replace x with c. When you will replace x with c, so 2c is equal to 4, and in this way you can find the value of c, that where the derivative of the tangent line is parallel to the derivative of the secant line. So at point c is equal to 2 is a point where the derivative of the tangent line is equal to the derivative of the secant line. To find c, whenever you are going to find the value of c, derivative of the to find the value of c, you have to find the value of the slope of the secant line and then take both of these equal to 0, so you can find c. There is another example for the function. The function is given x cube minus 12x, and the interval is also given. Mean value theorem exists here because the mean value theorem. How can you apply the mean value theorem here? Mean value theorem states that there exists a point C between this interval negative to 2, where the slope of the tangent line is equal to the slope of the secant line. So now I have to find f of b. So you have to find f of 2, because value of a is negative 2 and value of b is positive 2. And you have to find f of a, it means that f of negative 2, and divide with b minus a. So b is 2 and a is negative 2. When you will solve, your value is negative 8. And in the same way, find the derivative of the function. Okay, so in this how you will solve the question according to the mean value theorem. First find the slope of the secant line, and then find the slope of the tangent line. For finding the slope of the tangent line, you have to differentiate the original function. After differentiating the original function, replace x with c, and then you can find the values of c. These are more of the examples. These are all about the mean value theorem. Same steps are here. So hope so these examples are clear to all of you. So if you have any question, you may ask. So in live session, you may ask any question regarding to this topic.